Good day. Today we will be discussing about Charles' law. Charles' law states that the volume of a gas is directly proportional to temperature expressed in Kelvin at constant pressure. Let us analyze Table 1, which shows the effect of temperature on the volume of a gas at constant pressure. The first column shows volume expressed in ml. So let us analyze the given data. As we go downward, what do you notice with the volume? Does it increase or decrease? Yes, the value for the volume decreases as we go downward. Okay? For the second column, we have temperature expressed in degree Celsius. So when we go downward, you will notice that the temperature value decreases. On the third column, we have temperature expressed in Kelvin. In Charles' law, the temperature must be in Kelvin scale. So what are we going to do is to convert the value for degree Celsius to Kelvin. So how are we going to convert that? The formula is Kelvin is equal to degree Celsius plus 273. So it will go like this. 65 plus 273, the answer is 500. 60 plus 273, so we have 450. 50 plus 273, 400. And 45 plus 273, 350. 40 plus 273, 313. So the temperature values as we go downward still decreases. Okay? Now, on the last column, we have here the constant value when we divide volume with the temperature expressed in Kelvin. So that is 7.9 divided by 500. The answer is 0.16. 7.2 divided by 450. The answer is 0.016. 6.4 divided by 400, 0.016. 5.6 divided by 350, 0.016. And the last one, we have 5.0 divided by 313. Still, the answer is 0.016. Since we have the same answer when we divide volume with temperature expressed in Kelvin, it means that there is a constant proportionality between volume and temperature of a gas at constant pressure. Now, if we will have those data and show it in a graphical form, it will be like this. So, on the x-axis, we have volume expressed in ml. On the y, we have temperature expressed in Kelvin. So, this line graph shows the direct proportionality between volume and temperature of the gas when pressure is held constant. So, Charles' law leads to the mathematical expression B sub 1 over T sub 1 is equal to B sub 2 over T sub 2, assuming that pressure remains constant. So, we will use cross multiplication here. So, that is B sub 1 times T sub 2. So, B sub 1 times T sub 2, and then B sub 2 times T sub 1. So, we will have this general equation for Charles' law. So using the general formula for Charles' law, we will come up with these formulas, different formulas in solving for initial volume, final volume, initial temperature, and final temperature. But how do we come up with these formulas? So it will go like this. If you are asked to solve for the initial volume, what you're going to do is just to transpose T sub 2 here. Okay, T sub 2. And then cancel it so that we can get the general formula for B sub 1. So that is B sub 2 T sub 1 over T sub 2. Okay. So the same goes with the different formulas. So for example, we have B sub 2. So if you are asked to solve for B sub 2, you will just have to transpose T sub 1 here. So transpose T sub 1 so that you can cancel it. Cancel T sub 1. So we have B sub 2 is equal to B sub 1, T sub 2, and then T sub 1. Okay. So that is how we get the different formulas in solving for a problem involving Charles' law. Okay, so these are the different formulas. So let's have sample problem number 1. Suppose there are 20 liters of a gas at 20 degrees Celsius. If the pressure does not change, what will be the volume of the gas at 0 degrees Celsius? So how are we going to solve this problem? So still we will apply GRESA method, that is given, required, equation, solution, and answer. So we have a given temperature, initial temperature, which is 20 degrees Celsius. So just like what I mentioned earlier, the temperature must be in Kelvin scale. So we will add 273 to the given value in degrees Celsius. So that is 20 plus 273. Then we have 293 Kelvin. For the final temperature, we have 0 degrees Celsius plus 273. So the final temperature is 293 Kelvin. Initial volume, 20 liters. And you are required to solve for final volume. So the formula is B sub 2 or final volume is equal to initial volume times final temperature divided by initial temperature. So solution, that you will just have to substitute the given quantities. For volume, we have 20 liters. So we have 20 liters here. And then we will use the Kelvin scale. So we have 273. And then final 273 as the final temperature. And the initial temperature is 293 Kelvin. So you need to cancel the same unit and then multiply 20 times 273 divided by 293. So the final answer is B sub 2 or final volume is equal to 18.63 liters. Let's have sample problem number 2. A gas sample has a volume of 500 ml at 27 degrees Celsius. At what temperature will its volume be reduced to half? So let's have the solution now. Given initial volume, which is 500 ml, final volume is 250 ml. So how do we get 250 ml? Remember that in the problem, you are asked to determine the final volume that is reduced to half. So that is 500 divided by 2, and the answer is 250 ml. And then for the initial temperature, we have 27 degrees Celsius. You need to convert this to to Kelvin. That's why we will add 273. So 27 plus 273, we have 300 Kelvin. So you are required to solve for the final temperature. And the formula is final temperature, or T sub 2, is equal to final volume, or V sub 2, initial temperature, or T sub 1, divided by B sub 1. Solution. So just substitute the given quantities. The final volume is 250 ml, and then initial temperature is 300 Kelvin, initial volume 500 ml. So still you need to cancel the same unit. In this case we have ml. So 250 times 300 divided by 500, the final answer is 150 Kelvin. To check your understanding, try to answer this practice problem. At 350 ml, carbon dioxide is at 350 Kelvin. What will be its volume in liters if the temperature is changed to 400 Kelvin at constant pressure? Okay, so you are asked to solve for the volume in liters. Okay, and the given initial volume is expressed in ml. So try to solve this problem before you go to the next slide, which shows the correct answer. Okay, let's start with the given quantities. So we have initial temperature, which is 350 Kelvin, final temperature 400 Kelvin. The initial volume is expressed in ml, that is 350 ml. So you are asked to solve for the final volume expressed in liter. For that, you will have to convert ml to liter using the conversion factor. 1 liter is equal to 1000 ml. So just rewrite the given quantity, that is 350 ml, then we have times and then bar. Since ml is the given unit, that will be on the unit on the denominator. So you are asked to solve for liter, so that's why we will have it on the numerator. Then just copy the value from the conversion factor. So we have 1 liter, so we will place 1 here, and then ml 1000. So we will place 1000 on this part. Then you will have to cancel the same unit. So that is 350 times 1 divided by 1000. The answer is 0.35 liters. So 350 ml is equal to 0.35 liters. So the formula that we're going to use is B sub 2 is equal to B sub 1 T sub 2 over T sub 1. For the solution, we have B sub 2 is equal to, just substitute the given quantities. So initial volume, we will use the value in liter. So that is 0.5 liter. And then final temperature 400 Kelvin. Initial temperature 350 Kelvin. So you just have to cancel the same unit, then multiply 0.35 times 400 divided by 350 Kelvin. And the final answer is 0.40 liters. Did you get the same answer? Very good.